Welcome to section 4.14. This is the 49th session of the ISACA CISA exam prep series. In this session, we'll cover data backup, storage, and restoration. We'll answer several questions. How do you make storage itself resilient? What are the essentials of backup and restoration? How do you control offsite and cloud backups? What devices, media, and schemes can you choose? How do you rotate and test backups? And what is the simple strategy that ties it together? Why does this matter beyond the exam? Because for most organizations, data is the crown jewel. Picture a law firm hit by ransomware overnight, or a retailer that loses a day of sales records. A good backup is the difference between a hiccup and a catastrophe. It is your last line of defense when everything else fails. Get it right, and you recover cleanly. Get it wrong, and the data is simply gone. How do you make storage itself resilient? One common method combines many disks into logical units. It is a redundant array of independent disks. It improves both performance and reliability. Vendors wrap this in storage arrays. An array hides the complexity of forming volumes from physical disks. Still, your staff must understand the trade-offs of each configuration. Arrays also replicate data to guard against site failure. That replication comes in 3 flavors. Synchronous waits until the other site confirms each write. Asynchronous copies on a schedule, with some delay. Adaptive switches between the two as network load changes. Array-based replication is invisible to the application. And if there is no array, host-based replication does a similar job from the server. What are the essentials of backup and restoration? Plan it around your impact analysis and recovery objectives. The aim is to minimize data loss within budget and business goals. You store copies on secondary media for safekeeping. Even cloud backups live on a physical server somewhere. A cloud backup just means storing copies on a provider's infrastructure. It trades local storage for scale and accessibility. Here is a control worth memorizing. A backup should be immutable. That means it cannot be altered, deleted, or encrypted by anyone. Not even an administrator. Think of it as data set in concrete once written. How do you control the offsite storage library? Strict controls protect data physically and logically. Limit physical access to authorized people only. Encrypt the media, especially in transit. Make sure the building resists fire, heat, and water. Locate it away from the data center, beyond the same disaster. Keep a maintained inventory of everything stored. Log every item moving in and out. And keep a protected catalog of file versions and locations. Retention always follows the enterprise policy. What changes with cloud backups specifically? The principles are similar, but a few controls stand out. Encrypt the data as it travels across the internet. Encrypt it at rest, and restrict the keys to staff who truly need them. And verify your restore times truly meet your objectives. Here is a trap auditors catch. A restore test usually runs on a small sample, but a real recovery might pull the entire infrastructure across the network. That full transfer could take far longer than the test suggested. How secure must the offsite facility be? Just as secure as the original site. Think secured entries, an absence of windows, and constant monitoring. It should not be easy to identify from outside. That deters deliberate sabotage. It needs the same environmental monitoring. Control humidity, temperature, and air quality for the media. Add an uninterruptible power supply, raised floor, and fire suppression. And make sure paper records do not become a fire hazard. One more reminder on backup data itself. Duplicate the important data and documentation off-site, and give those copies the same protection as the originals in transit. What devices and media can you choose from? Pick based on 4 factors. Standardization, because exotic technology costs more to support. Capacity, so you need fewer pieces of media. Speed, so backup and restore finish in an acceptable window. And price, including the cost of the media itself. Media splits into removable and non-removable. Removable includes optical discs, drives, and tape systems. Non-removable is mostly disk-based backup. Let me unpack the disk-based options. A virtual tape library mimics tape while writing to underlying disks. Replication driven from the host relies on dedicated server software. The array can drive that same replication itself, unseen by the servers. And snapshots capture momentary copies of volumes or files. Snapshots are especially efficient with backup software. In a virtualized environment, you can even replicate whole virtual servers. How often should you backup and rotate? Backup both data and software, following your recovery point objective. Data folders change daily, so back them up often. Configuration and software files change less, so back them up less. High-volume systems may need hourly backups or live replication. Automate the scheduling to prevent missed cycles from operator error. Modern tools use agents on each protected machine. Those agents collect the data and ship it to backup servers. The same agents handle restoration. A few rotation rules matter. Set the backup frequency and retention depth for each application. Assume any stage of processing could break down. Remember that databases need specialized backup. You may need a software license ready at the alternate site. And custom software backups need both object and source code. What exactly gets rotated off-site? More than just the data. Store operating procedures and runbooks. Store system and program documentation. Store any special or exception procedures. Store key input and output documents. And store a current copy of the continuity plan itself. Sensitive media belongs in a fire-resistant container, and every organization needs a policy on what to keep and for how long. What are the 3 backup schemes? Full, incremental, and differential. A full backup copies everything into one set. It is the simplest to restore, but needs the most time and space. An incremental backup copies only what changed since the last backup. It is fast and small to create, but restoring means replaying every increment since the full backup. A differential backup copies everything changed since the last full backup. Its data is cumulative, so it grows each day. But you only need the full plus the latest differential to restore. Think of it as a trade between backup speed and restore speed. In practice, teams combine these schemes to complement each other. How do you organize the rotation over time? A well-known method is grandfather, father, son. Daily backups are the sons. The last backup of the week becomes the father. The last backup of the month becomes the grandfather. Daily media get reused the next week, but monthly and yearly copies are retained, not recycled. One safety rule stands out. Do not bring off-site media back until its replacement is safely off-site. Why is testing so important? Because an untested backup is just a hope. Testing confirms you can actually recover the infrastructure and processes. It identifies gaps and verifies your assumptions. It checks timelines and reviews how people perform. Many organizations require full testing every year. Test again after major plan revisions or big personnel changes. Plan tests carefully so you do not put the business at risk. Document every test with before, during, and after reports. and keep good records of offsite contents and media movements. What is the simple strategy that ties it together? It is the 3-2-1 approach. Keep 3 copies of your data in total. 1 primary copy and 2 backups. Store them on 2 different types of media. And keep at least 1 copy offsite. This shrinks the risk from a single point of failure. A media error or a stolen device no longer wipes you out. Just note that some cloud providers may not offer every part of this. So let's bring it together. Resilient storage uses disk arrays and replication. Plan backups around your impact analysis and recovery objectives. Make backups immutable and control offsite and cloud storage tightly. Choose media wisely and combine full, incremental, and differential schemes. Rotate with grandfather, father, son, and always test what you back up. And lean on the 3-2-1 strategy as your baseline. Master this, and your data can survive almost anything. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.